Hi and welcome. I'm trying to learn space science. Today, how many stars are in a galaxy? After we've done it, we're going to do short-term heterogeneity. Maybe you participate in short-term heterogeneity, then it's better to how this goes. So, how many stars are in a galaxy? First, the introduction. Galaxies and stars. A galaxy is a group of stars, gas and dust, held together by gravity. Let's start by looking at our own galaxy, the Milky Way. Okay, we're talking from the perspective of the Earth. The Earth is inside of the Milky Way. And now we're telling you how many stars are in a galaxy. And the galaxy these are a group of stars, or a bunch of stars, and also of gas and dust. And they are all held together by gravity, which puts them together. How many stars are in a galaxy? The Sun is one of at least 100 billion stars in the Milky Way. Okay, in the Milky Way, which is the galaxy in which the Earth is, there are 100 billion stars, and the Sun is one of these stars. So 100 billion, that is your answer. How many? 100 billion. These are really a lot. Many of these stars are bunched together towards the center of a galaxy. That's also interesting. So in the center of a galaxy, they are bunched together. The Milky Way is huge. Even light takes 100,000 years to cross it. That means light speed is very, very fast. The light from the Sun to the Earth takes 8 minutes. And the whole time light needs to pass through the whole galaxy needs 100,000 years. But in galaxy terms, it is just medium-sized. So again, they said it already true of the Sun, but the Sun is not essentially large. Here, the Milky Way is just medium-sized, with 100,000 light years size. The largest one ever spotted is called IC 1101. And has up to 100 trillion stars. That is much more. I don't know what calculation we use, but it's at least 1,000 times more than as are in the Sun or in the Milky Way. So there is, okay, we've spotted another galaxy, a part of the Milky Way in which the Earth of the humans on it is. And that other galaxy is called IC 1101. And that has 100 trillion stars. It is more than 50 times the size of the Milky Way. So the size of the Milky Way is already 100,000 years does light need to travel through it from one side to the other one. This other galaxy which was spotted is 50 times as large as it. That means that the light needs 5 million years to travel from one side to the other. Can we visit the other stars in our galaxy? Our nearest star apart from the Sun is called Proxima Centauri. Okay, there's the Earth, and people can half a day look up and they can see there's somewhere the Sun. And the Sun is a star, and there are other stars in the Milky Way. And our next closest one to the Sun, which is 8.5 light minutes away from the Earth, is Proxima Centauri. And now, can we visit it? At more than 40 trillion kilometers away, even our fastest spacecraft would take thousands of years to get there. It was not a no. In a way, it was a yes. So we have to travel 40 trillion kilometers when we're starting from Earth. 40 trillion, that's a lot. Let's try to understand that number. It's way too much number to understand. It would take thousands of years to get there. So we would need thousands of years if we could travel from the Earth to Proxima Centauri. Proxima Centauri, I don't know what that is. No, that must be with Proxima Centauri, but I don't know if it's a photograph or whatever. That is for Proxima Centauri. Okay, that is Proxima Centauri, basically just another sun. And Proxima Centauri is a fairly small, dim star. We can't see it in the night sky without a very powerful telescope. That means it is a star, it is a sun, but it is a dim star. That's the first reason. The second reason is probably that it's quite far away. No. The other stars which people can see from the Earth out in the sky at night are also stars. So they're just, let's think about it in a moment. That means, if you read between the lines, when humans look from the Earth out in the sky at night, they can oftentimes see stars. And these stars are other stars, other suns. And this Proxima Centauri, the nearest one to the Earth, can only be seen with powerful telescopes. That means that the other stars are brighter. So we don't see the closest one when we look from Earth. Okay, the other thing, the center of our own galaxy is a cluster of at least 500 million stars. 500 million. We talked about 100 billion in the Milky Way. No, million is less. I don't know what calculation we use, at least 1,000 times less. The center of our own galaxy, so of the Milky Way, is a cluster of at least 500 million stars. It is one of the brightest things we can see in the night sky. Okay, we have that here. That could be actually a photograph. I don't know if it's something which people sometimes actually see, but that is the center of the Milky Way. Do we get enough of it? Now, why can we see it if we are ourselves in the Milky Way when we're making such pictures? It is because the Milky Way is, we're basically on the outside a little bit and we can see the center. So it has such like arms, I don't know how to really explain it. So arms like that or something like that. And in the middle is the center. And all around can see into the center. And we are somewhere here on an outside arm and can see the center of the Milky Way. We saw actually way more information than I thought it would be. What was it? Way too much to recapitulate actually. Okay, a galaxy is a group of stars and gas and dust. It's way too complicated. Humans live on the Earth in the Milky Way. And the Milky Way has 100 billion stars and 500 million of them are in the center, bunched together. It takes for the light 100,000 years to cross from one side of the Milky Way to the other one. That means if this photo is taken on one of its outside arms to the center of a galaxy that is 50,000 years old, this constellation. Because it took 50,000 years from there to see. So 100,000 years does light take, and there's another galaxy seen. The largest one which was found so far by humans is the IC1101, and that has 100 trillion stars and is 50 times as large. 5 billion light years, I think that across. And from Earth out, the closest star is the Sun, and the second closest is Proxima Centauri. It is 40 trillion kilometers away, and it would take thousands of years with a human-made spaceship to go there. And it is not the brightest one on the night sky. It is a fairly dim one, and it can be seen only with powerful telescopes. I spotted something else in this book. Not enough for a standalone video. Let's go shortly to it with my phone. Why do the Sun and Moon look the same size from Earth? I don't think we did that. No, the answer is, although the Sun is 400 times wider than the Moon, and these are, we have it here, 1.4 million kilometers across, it is also about 400 times further away. This means that the Sun and Moon look the same from the Earth. And here was 150 million kilometers away. Okay. The Moon is 300,000 pretty exactly, I think was it 300,000 kilometers away. Did I say it somewhere? No, I can't remember what I said. Okay, the Sun is 150 million kilometers away. The Moon 300,000. Is times 400. Whatever the answer is, it is 400. Okay, we showed it here a little bit of solar eclipse. What is a solar eclipse? And there the Sun is blocked by the Moon. From Earth, the Sun and Moon look the same size. This is why the Moon can block the light of the Sun in a solar eclipse. The Moon is much closer to the Earth, the Sun is much farther away, 400 times away. But the things which are closer to the eye appear to be larger. Okay, we're going to come back in the next video of Space Science, and where we try to make a little explanation or presentation about actually answering this question and precisely why is the Sun looks the same size as the Moon, and also the other thing with what we had here about this galaxies where there are 100 billion stars in the Milky Way, that it takes 100,000 years to cross from one side to the other one, that there in the cluster are 500 million stars, that the IC1101 is the tallest one which humans has yet discovered, with diameter of 5 million light years, and that there are 100 trillion stars, and that Proxima Centauri is the second closest one to Earth after the Sun, with 40 trillion kilometers. Right. That means if you were here for Space Science, you can go directly to the next part of Space Science if you stay and participate in the short and heterogeneity when it's at the put in stable stance. And we're doing shoulder circles. We come back, up, front, down. And now backwards, front. And now, long arms, strong fists, and go as far back as you can with the shoulders. Up, front, down, and again back. Up, and in front, and down, and again up. The other way around. Back, down, front, back, and down. Now we're accelerating motorcycles into the knees, hinge forward to the straight back, get the arms hang, pinch the scapulars with it together. Fists, lift the arms up and still pinch the scapulars together. The arms down, and the shoulders, and another round, pinch the scapulars together. With it. Big fist, lift the arms up and still pinch the scapulars together. Stop, shoulders down. And now a sheet jumper into the knees, hinge forward with a round back, let the arms hang, big fists, turn the arms up inside, lift the arms high up, bring them together, straighten up, shoulders down, together. So arms high up and together, shoulders down, together. Release, and the second round, into the knees, hinge forward with a round back, let the arms hang, mixed short and fists, turn the arms to the inside, the arms high up and together, straighten up, bring your shoulders down, together. And release. Now just lift the arms up. If this exercise causes pain, then don't do it. And the arms to the side, in front. Just observe what the scapulars are doing. And the next exercise, the word lifter. Long arms, strong fist, shoulders down and together. Now turn the arms to the inside. Arms to the outside, shoulders down, together. To the inside, have a fist and shoulders down, together. Arms to the outside, shoulders down, together. And release. Arms up and a bit in front, turn the arms in front, shoulders down, and together. Arms back, shoulders up and in front. And arms in front, shoulders down and together. Again, arms back, shoulders up, front. And release. And now we'll shrug, arms up, and shoulders up, and release her down. And the arms up, shoulders up, and go down. And last time, arms up, shoulders up, and go down. And now, repeat the arms together, a bit down into the outside. And next exercise with sunlight. Use a sock, have it with a long arm at the outside. Let it fall down. Try to catch it again. On the other side. Now stretching. One arm in front, shoulders back, and down. Pull the arm in, flat fingers, try to relax the arm. Go it back with the shoulder, turn the palm up to the sky. There we go. Front, shoulder back, down, pull the arm in, try to relax the arm. Go it back with the shoulder, pull the arm. Palm up to the sky. Das was für schon ein Impingement. I thank you very much, and until next time.